Hello, in the last episode I showed how to plot tiles and groups of tiles. In this episode I will cover the basics of moving actors made from tiles around the screen. When tiles are put into the tile map, they stay there until you overwrite them or the Gameboy is switched off. When you move tile actors around, they will leave tile parts behind, which means we need to draw and erase each time, as I will show now with this image here. If we move one tile to the left and redraw, you will see that the right side of the actor is left behind. If we were to move up by one tile, you'll see that the bottom part is left behind. So what we need is routines in place to erase horizontal strips and vertical strips, like this vertical strip here or this horizontal strip here. I will now demonstrate this in code. So to begin with, we need to create our new project from our old one. So if you select the previous project, copy and paste it, and then rename to BG Tiles 2. Then go into there, delete the GB file, open the codeblocks project in a text editor, like so, and then rename inside to BG Tiles 2. This is the title of the codeblocks project inside of it, and this is what the name would be if we were not using the custom makefile project. So save that, then open that up in codeblocks. First off, we need to alter the makefile to the name of our new project, which is BG Tiles 2. Then close that. Now, using our old project as a template to build off is obviously a nice quicker way to start. So now I will cover the new stuff that we need. So first off, we need to include a new header file, rand.h. This is GPDK specific. It's not actually a header file in the normal C libraries. Next, we need to add in a custom define for the amount of, this will limit the amount of actors we can draw at any one time. And here's a new data type for us to use, which is a 16-bit unsigned short. Next, we need to add another global variable that we'll be using. So we use this to seed the random number generator at the beginning. It's also a good idea to continually update the value of it, and every now and again call the initialize rand function, which I put in to reseed it to stop the numbers from becoming too predictable. Next, I have some more custom enumeration types for us. And I also have a struct to hold our actors group. So because we'll be moving loads of them around, we kind of create a framework for them all. So by just referencing this type here, we can control the properties of all of our actor types here. So you see there's arrays defined in here to hold all of the properties of our actors. So we've got the horizontal and vertical positions of them, the tile start ID, the direction they're facing, the movement type. So you see that the movement types here can be bounce Y. This is just for actors which will bounce vertically. This one is for actors which will bounce horizontally, and this is for actors which could bounce X and Y. It will make sense when you see the project running. You could obviously add more to these. These are kind of like expandable properties, if you like. And then this here is a quick way to hold bit flags for our movements. And then this just signals what our animation type will be. All of the ones we'll be using in this project will be looping, but you could obviously build up all of these. And then we've added the amount to start with 50. As these are tile actors, you could put however many you want in there, but the more you draw, the slower it will get. And then our next two functions here. This initializes the random number generator, which you need to do in C. And then this command here will return an 8-bit number between 0 and the maximum number value that we want, which we'll pass in here. And then our final two functions are tile clear strip X and tile clear strip Y. So now we've defined the prototypes for those functions. Let's fill them out. So every time you create an extern variable type, always make sure you put it somewhere. So it doesn't necessarily have to be in the source file of the same name. It can be anywhere, but I put it in here because this is where we kind of want to use it. Here's our random functions here. So what I'm trying to do here is take the value from one of the timer registers and use it to seed the random number generator inside GBDK. So this command here, init_rand, is the function to initialize it, and it takes a 16-bit number, hence why we're passing lseed in here. This is just trying to do something with it to maybe make it not as static each time. And this is the actual function, and this is the function which gives our random number. So we've got a temporary variable in here which takes a number between 0 and 255. We then use the mod function to clamp that value to our maximum value and then return that. I would recommend to have a play around with all of this until it makes sense. Now the clear strip X function, what we first do is get the starting address and the tile map of our start location here. We then fill that with zeros to clear out the width segment. So this will right outside of the tile map if you try and draw outside of horizontal 0 to 32 or vertical 0 to 18 on the screen. There's no sort of boundary check in here. This is just to quickly get it done, so be aware could cause issues if you put numbers which are outside of the tile map range in here. And then the vertical clear tile command does a similar thing. Get the start location, but then because the tile map actually has 32 tiles in width, to go one down we add 32 to the address value returned here, and then put in a 0 tile here. So that's those two here, that's the main sort of things there. Next go into the main header file, and then we've only got one new thing to add in here, which is the anim delay constant. So the reason why I use defines for all of these is it's easier to change or tweak things by having them set in a header file as a define. So that's all for that one. Next we need to pretty much remove everything from here. As we're not adding any tiles, we can leave that the same. Oh, get rid of that, and we'll get rid of that. So here we call our actor group actors. We have a temporary variable here to, a global variable to indicate whether they've moved or not. If they've not moved, then there's no need to erase parts of them. And then I'll copy in big chunks of code here. So this huge block here initializes our actors first off. These are some temporary variables. So first off we need to initialize the variables in our actors group here. So first we set the count, which is the amount of them there are, to 0. I didn't explain that, but if we go back to here, you see these are not arrays at all. These are just there to indicate how many actor types we actually have in the array. And then the frame ID is to hold what starting animation frame that they have. So first part here creates our actors which move horizontally, and then our next line creates a group of actors which move vertically. Sorry, it's the other way around actually. These are the horizontal actors and these are the vertical actors. It'll become clear when you see the code running. And then to move our actors which move vertically, this works on an individual actor here. So first off we check to see whether the actor is facing down. If it is, we first check to see whether it's at the bottom of the screen. If it reaches the bottom of the screen, then we change it to facing up the screen. And then if it's not at the bottom of the screen, we move it down a tile. We then indicate that it has moved. If it's not facing down, we check to see if it's at the top of the screen. If it is, we change it to facing down. If not, we move it up. And then that's all that that block there does. And then our next block of code is for moving actors across the screen horizontally. We check if they're facing right. We then check to see whether they're at the rightmost tile on the screen. If they are, we flip them to facing left. If not, we move them right and then indicate they've moved. If they're facing left, on the other hand, we first check to see whether they're at 0, which is the left hand tile. If they are, we change them to facing right. If they're not, then we subtract their horizontal position by 1 and set that they've moved to true. Just quickly going over this here, it will all kind of make more sense when you see the program running. And here we have our main block of code which handles moving all the actors. So these are a load of temporary variables to help us handle working with the data from our actors groups. It's always best to copy the value from arrays into a temporary variable first to work with it, and then copy that temporary variable back to the location in the array, just so that it helps to speed things up. So we put the move type into T each time. So first off, we loop over all of the actors in our array first. So if you change the amount of actors in the array, this will obviously affect all of this here, so it kind of handles it all for us. All of these things here are obviously set up in the init function up here. So what we do is we first get the type, we then get the vertical position, horizontal position, what direction it's facing, and its starting tile. If its animation type is static, then we get the frame into G and then just add the starting frame times 4. And then depending on what type, whether it's a move vertical or move horizontal, we call the move actors function. So for the Y, actors that move on the Y axis, we pass by reference the Y variable here so that the value can be updated in the function and it will affect it on return. Same with facing. We then repopulate the facing variable with the returned value just to make sure that if it's been changed, that it's reset in the actors group here. And then the same thing with the move on the X location. If they have moved, then first we draw their new location. We then update their horizontal and vertical position and their facing position again. We then check what direction they're facing in. This is important because we need to erase only the parts that they leave behind as they're moved. So if they're facing down, we erase the tiles above them. If they're facing up when they moved, then we erase the tiles below them. Same with if they're facing right, we erase the tiles on the left. If they're facing left, we erase them on the right. Then at the end of moving and operating on all of our actors, we then change the frame by 1, and then if it equals 2 we reset it back to 0. That was a quick go over of the main code block there. It will all make sense when you kind of see it running, and then you'll probably have to have a tinker around with it yourself to kind of get a good feel of what everything's doing. So now this is our main code here. So at the start of that, we need to initialize our rand function. We then need to initialize our timer with the anim delay value, and then before we go into the while loop we need to initialize all our actors, so we place them in their starting positions. Then we update our animation timer. So the animation timer controls not only how fast the actors animate, but also how quickly they move as well. So if you tinker around with the value here, you can get them moving around stupidly fast. So you'll see once our timer has elapsed, we reset the timer and then move the actors. And that should be it. Now if you save everything and then build, happy days, we've got no errors, which is always good. Now if we navigate back to here, and now if you open this with Emulicious, this is what you should see. Now you see these are the vertically moving ones here, which bounce around when they get to the bottom of the screen, and these are the horizontally moving ones here. You see that I staggered them by one tile at the start to make it more obvious what's happening. Because they're moving tiles at a time, you'll see where they overlap, they sort of destroy each other. Again, only one tile can occupy a space on the tile map, and they also move quite blockily. But there is a place for having tile actors. If you think of a game like Space Invaders, where there are too many enemies to actually be sprites, they are all done with tiles. So you can create huge amounts of enemies with tiles. And that's it for this video. I'll now start linking code projects in my SourceForge page, so link for that in the description. That's it for this video.